Thanks so much for joining us today. If we've not met before, my name is Maggie. I'm the Community Product Manager for Data Hub. So my focus is on making sure that folks in the Data Hub community have the tools and resources they need to be successful with Data Hub. Today we are having one of our maybe very first panels and AMAs outside or just kind of an ad hoc or one-off panel. So super excited to bring you onto the conversation. Let's start off with a couple of rounds of introductions. Chad, I'll go ahead and kick things over to you for an intro.
Thanks, Maggie. My name is Chad Sanderson. Most recently, I was leading the data platform team at a company called Convoy. It's a late-stage startup based out of the Seattle Bay Area in freight technology. Prior to that, I was working at Microsoft on their artificial intelligence platform team. And before that, I was in big data at a variety of other companies, Oracle, Sephora, Subway, and then in a different life, I was a journalist living in Southeast Asia and writing for about 4 or 5 years. Most recently, I'm running the Data Quality Camp community. This is a Slack channel, and this is where Maggie and I started talking and how we set all this up.
Awesome. Shashanka?
Hey everyone, I'm Shashanka, co-founder and CEO at Acryl Data. Prior to this, I spent almost a decade in data in the company known as LinkedIn, now a Microsoft company, but still I think has a pretty strong brand on its own as a tech powerhouse. Most of my time there was spent kind of as a builder and then later as an architect. As part of my time there, I founded the Data Hub project. Initially, it was a search and discovery solution, a classic catalog, if you will. And then over the years, it became kind of a more operational metadata platform, powering a lot of like metadata registry style use cases. And at LinkedIn, I was responsible for data platform strategy that included, tracking event strategies and enabling large migrations where we rewrote the production stack multiple number of times. And we had to do that while still keeping downstream data flowing and high quality. And so that was an interesting journey for me at LinkedIn and learned a lot of things. One of the things I learned as part of that was that, good fences make for really good neighbors and, data contracts. I'm a big believer in that kind of a philosophy. And so I'm really glad to be here talking to you all and with Chad, who's kind of made this, really taking it from an idea to something that everyone is talking about. So kudos to you for that.
Definitely. All right, so let's talk kind of high level goals for the session. So we only have an hour, time flies, these sessions go incredibly quickly. So we're gonna break it into 3 parts. First and foremost, we're gonna talk about just kind of like defining data contracts. So we're kind of level setting with the group, right? Like what exactly is a data contract? Also, what is it not? Maybe we can get into that. What are the roles, responsibilities behind it? And then from there, we're going to be talking about why even bother with data contracts. So kind of the core use cases behind it, figuring out what problems they solve, what alternatives exist. And then we also in the last section want to get really concrete about how to actually implement or how to start building them into your data stack. I was actually talking to Shashanka about this earlier this week. I have a hunch that folks already have semblances of data contracts within their stack. So let's figure out how we actually make those a powerful component to the actual data stack. If you look in chat, and if you RSVP'd through the event, you will have gotten this link as well. But I just put it in chat. It's a link out to a tool called Slido. This is where we're going to be crowdsourcing questions. So you can go ahead and keep an eye there. If there are questions that other folks have asked and you want to kind of bubble those up to the top, please feel free to give it an upvote. In each of these sections, we'll try to look for questions that are associated with it. But also if you have questions or topics that you're interested in, feel free to leave it in there. And we will go ahead and pull in those questions as makes sense. So let's go ahead and kick things off. We're going to start with defining data contracts. So Chad, I'm actually going to start with you on this one. From your perspective, what makes a data contract, and kind of what are the core requirements for it?
Yeah, I think that's a good question. So contract is one of the reasons that the name I think has taken off is because there are parallels in the software engineering world, service contracts, APIs, and data contracts are very similar, at least in spirit, except they apply more towards some of the specific requirements that come from the data world. So at their core, a data contract is an agreement between a producer and a consumer on what data needs to move from one source system, from a target to a destination. What is the shape of that data, its schema, and the semantics around it. And on top of it, if that contract is violated, how is that violation enforced, ideally through some programmatic means?
Awesome. And Shashanka, I'm curious, do you have any thoughts to add in there, like anything to kind of like help give folks a clear idea of what we mean by a data contract?
I think this is a pretty reasonable description. There's a couple of things that I've definitely noticed people talking about, which is beyond the specific aspects around schemas and quality assertions, broadening it further to data management specifications or data provisioning specifications, almost kind of making it like a data definition, almost like a declarative data definition for a data asset versus purely a contract. I think it's an interesting idea, definitely, to expand the scope of the contract beyond just the quality aspects of it. So that's probably something I would say is a stretch goal for a data contract if it were to have OKRs.
So I'm curious, my background is in kind of like analytics engineering, data engineering. I think we have a lot of folks in the call who are kind of a similar background. How does a data contract differ from kind of a data set DDL? So kind of like the schema level definition of a data set, for example, or maybe other ways that you can kind of define both the semantics or kind of like the structure, the physical requirements of a data set.
Yeah, I can take that one. So the way that I look at it is that schema definition is certainly one component of the contract, but it's certainly not all there is to the contract, right? That sort of maybe to I guess we're going to talk about this in the use cases a little bit more in the next section, but just at a very high level, the point of the contract is really twofold. The first is that it's a surface to generate a collaboration around what is the data that is needed and how is that data actually used downstream. So you need to have some artifact where that conversation can happen. That's number one. And then the second is, like I mentioned, it's more expansive than just the schema, although the schema is certainly a part of it. It's the schema, it's the values, it's the business logic. So for example, if I have a column, and when I worked at Combo, it's all about freight. So I might have a column called shipment distance in miles. And if a software engineer decides to change the underlying business logic from miles to kilometers, that's not something that anything that is handling schema checks would ever be able to account for. But it would be included in the contract because the semantic definition has changed in the same way that you can't change the underlying semantic meaning of an API without actually breaking that contract. So I would say the schema definition, if you're using a schema serialization framework like Protobuf or Avro or something else, that schema is certainly a part of the contract, but it's not all there is to it.
Sure. Shashanka, I'm going to kick this one over to you. In terms of thinking about, so Chad was kind of talking about this agreement between the producer and consumer of that data. I think we're moving more and more, especially in the data mesh of it all, we're moving more and more into many teams or many functions being both consumers and producers of data, but oftentimes kind of these agreements or best practices or these standards established by a kind of data engineering function. And so I'm curious, from your perspective, what are the different roles and responsibilities of a data contract by both the producers and consumers of the data who may not actually be on a data engineering team?
Sure, I think,
or maybe they are, but
right, at least they know distinctly whether they're a producer or a consumer.
Yes, exactly. Yes.
Yeah, which actually some people don't, but yeah, I think that's a good question to ask. I would say that, just like Chad was saying earlier, a lot of this data contracts conversation has been centered around what are best practices that we can learn from software engineering practices that we've seen work well in other environments like the services stack. And actually, if you think about services themselves, how do APIs of services get created? Now, it turns out that a service doesn't usually just get created because someone decided to create a service. It often gets created because someone is building a product. And as part of building that product, they decide, well, I would rather like to, factor out this particular functionality into a separate piece and give it an API and, make it reusable because it seems like a reusable piece of technology and isolation, separation of concerns, all of that good stuff. And in that example, you've got a team that is both a producer as well as a consumer of their own service. They decided to pull out a service because they needed it. So actually the use case comes first. The use case for requiring an API comes first. So actually, if you look at data itself, the use case for data comes first. Like, why do you need this data asset? Like, what are you going to do with it? And from then on comes the desire so it's basically maybe a consumer that is saying, I need this data asset or this data to be produced. And then the producer actually says, okay, we'll produce it. And here's what the schema is that we can agree on. So if you look at even the simple example of one data set used only by one person or one team, you've got this sense of a propose approve kind of discussion that just happened where someone said, I need this. And that someone could be even a PM, right? I mean, at LinkedIn, when we ran the tracking events that were getting produced by the product application, the PM and the data science team would be kind of deciding what were the events that the app would emit. And that was essentially the consumer in a way. And then the producing team, which is the team that is actually writing the product, maybe we're launching a new email experience or something like that, or redoing our search homepage. That team would then decide, okay, where are the points to instrument and what are these tracking events going to look like? And that's where the contract starts getting created. So you've got the consumer that's driving kind of the requirement even for the asset to be produced, along with the things that they care about. And that's actually an interesting observation around the maturity of data practices. In many cases, the first thing you'll care about is just the schema, like at least get the structure, right? And then in other cases, as your maturity grows, you'll start caring about more things like, don't just tell me, like as Chad was saying, it's not enough to tell me what the shape is, tell me a bit more, give me the semantics of how things are going. And that's how it starts, I think. So the roles are very clear in the beginning. You've got a consumer of a asset and you've got a producer of that asset. It's clear who they are and they have negotiated something. Where I've seen things get pretty interesting and challenging is when you have a really widely used data asset or a data product, when you've got multiple consumers and a single consumer, a single producer. And I saw that especially closely as part of the metrics platform at LinkedIn. So we created a single repository, single source of truth for all metrics. We said, data science, you own all of the logic that goes for all of the metrics. So everything must be good, except it turned out that within a couple of quarters or a year of working on this metrics platform, we had 2,000 plus metrics. And we're like, how did we get to so many metrics? We had a single source of truth. What happened here? Turns out it was much easier for the different consumers of the same logical thing to kind of create their own little forks and kind of create a separate pathway to compute roughly the same thing. I just need a different cut. Oh, my logic is just a little bit special. I want, the test users excluded. You were including the EU users, the usual stuff that happens. And so I think the challenge, and so I'm not saying that this is a solution. I'm just saying that things get interesting when there are multiple consumers involved and there's a single producer. And what you want in a good data contract responsibility setup is the consumers are able to have effective contract negotiation. They're able to basically say, here's my expectations from this data product. The producer is able to acknowledge it and then decide if it makes sense to bake it into the contract as a global assertion, or to let consumers have their private assertions that might be specific only for how they are particularly using the data asset. So that's kind of the usual way in which we think about data producers and consumers. And I think, curious to hear if Chad has seen something similar at his experience at Convoy.
Yeah, I think that you summarized it very well. I think there's a few interesting things that contracts. So there's another sort of problem, and I didn't want to jump the gun too early, but one of the big challenges, in addition to having a single source of truth and then that source of truth being forked in many different places, and now you don't really have a source of truth anymore, is this issue of if you go further upstream, especially to the production databases, you usually have a misalignment of what the data in those databases is intended for versus how it's actually used downstream. And the reason for that is that I think of the data industry more akin to a design function than an engineering function in a lot of ways, not in every way, but in a lot of ways. Like if you're a software engineer, then there's a pretty clear path for you where we say, okay, we're going to go build some functionality. We think of the tooling and the infrastructure that we need to support it. We design our feature, we build the feature, then we validate it and test it and go through all the other motions. But in data, it's not quite as clear cut as that. Oftentimes the workflow is more akin to doing prototyping on the data that already exists. So we want to extract some data from all the databases that we have. Maybe we'll join it to a few interesting things. We'll run filters on it. Maybe we'll try orchestrating it in different ways. And then the problem is that when we're ready, when we have this data set that now has the ability to solve, either answer a really important question or has some other production use case, like a training set for a machine learning model, it's built on top of this prototypey, messy data infrastructure that was really never actually designed to scale. And then on top of that, you now have this separation where the service team that's sort of managing the data for the use case that serves the application is now potentially multiple steps removed from this downstream use case that is the result of iteration over a longer period of time. And so I think the other, sort of tying it back to something Shirshanka was saying, is like, I think the other the other way I think about producers and consumers in the context of data contracts is we need some way to bring these folks back together after those downstream use cases have been defined, and to say, okay, it's taken us maybe 6 or 7 months, but now we do have a schema that needs to be enforced, or we do have some semantics that we've decided are meaningful, and I need some upstream ownership just on these very specific attributes, which can be tied to business value.
Mm-hmm. Amazing. All right, let's go ahead and move on to our next session. And I'm actually going to kick this session off. So we're going to talk about why data contracts, right? So why should we even bother with them? We've talked a lot about kind of defining what they are, who's responsible for what, et cetera. And I'm going to start with a question from the Slido. And folks, I've added the link in chat a couple of times, so you should have access to that as well. But so the top voted question is, how do I best describe data contracts in value terms with minimal jargon for senior stakeholders, i.e. people or those with the purse strings to fund the strategic priorities? So when we're thinking about why data contracts, if you could, I don't know, maybe I'll challenge you to each to distill why data contracts down into a couple of sentences with minimal jargon.
So what I would say, I would say that the best way to describe data contracts is a mechanism to ensure that your revenue generating data assets don't break or are treated as part of the product.
Shashanka, do you have something else to go along with that? That's a good one.
The one I've used successfully in the past is you manage the rest of your software as code, so why aren't you managing data as code?
Fair. That's extremely fair.
I actually haven't used the word data contracts or the phrase data contracts by itself, but more like the principles of managing data using software engineering practices. I think that I found resonates a lot because execs are used to the benefits of that in the rest of their ecosystem. And so they realize that it should be the normal way to do things. And that generally resonates. But that's when you're starting from scratch and you're asking for maybe a whole new initiative or going up to your CEO and saying, we don't have a data quality program and we need to start, or something like that. But I would say the most effective way to actually start on getting data contracts, funding in your company is to not boil the ocean and actually to take advantage of existing initiatives that might be going on where you're either rebuilding a certain section of the data stack or you are going through a big migration and you use that as a mechanism to actually say, so this is born out of actually my practical experience where, in 2015, LinkedIn was rewriting its whole stack, like the mobile app was getting rewritten. And when we did kind of the analysis on what that would mean, it meant that every single tracking event that we had in the past was going to look very different. And so all of the analytics we had downstream of that and the models and everything would just go off. We would have page views getting counted incorrectly and things like that. And so, of course, there were two options that we had as a team, which is one, rewrite all our metrics computation and feature computations code to conform to accommodate the new model change that was about to happen, or to do that and put in the foundation that would allow us to make another change happen with less effort. And so when we did the math on how much time it would take for us to just rewrite all the scripts and just accommodate the new models versus actually put in the foundation for an intermediate layer that would give us that ability to have that data contract in the middle and then do the rework, it actually netted out to be a little bit less than what it would have cost us to redo all the work anyway. So that's what we ended up doing. We redid the mobile app and we put in a data contracts like foundation layer in the middle between producers and consumers. And then we rewrote the mobile app counting logic. And then later on, when we did the desktop rollout and we redesigned that, we were able to roll out the changes to that much quicker. So I think as long as you pick the right initiative to accomplish your transformation with, I think good things can happen. And people like a good opportunity to rebuild things in the right way.
Yeah. So let's dig in a little bit more. So Shashanka, you started with, kind of like a full refactor of a code base, kind of starting things small or starting with a like high value initiative and kind of implementing this in a smaller subset portion of a stack. I'm curious, what are kind of the additional core use cases for data contracts? What problems are they being solved, or and the kind of the problems that are solved along with it, in addition to what we've already discussed? Or like, have we missed any kind of core use cases?
I think, we've talked about definitely schemas and quality specifications. I think people understand that pretty well. We've not talked much about service level objectives or SLOs. I think those can be quite useful when you can provide guarantees about not just what the data looks like, but also when it'll be available for processing. That's still, again, a quality-oriented, operational quality, perhaps, of the data asset. And the other thing that I think I've found a lot of success with is describing data management requirements within the same specification. So being able to say things like, I would like this data set to be provisioned in the PII-free cluster. So we, for example, when we did GDPR, we had to kind of go and create a separate cluster where all PII was cleaned up and anonymized so that our data scientists could have a pretty, continue to enjoy democratized, easy access to data and be able to do exploratory analytics without requiring jumping through a lot of hoops. And so we got in kind of specifications around tag masking, retention, and those kind of policies into the contract language itself. So that gave data producers the ability to request certain things declaratively. And that was, I think, a pretty cool way to extend this idea to include data management specifications as well.
Awesome. I'm curious, Chad, are there use cases that you can think of that we haven't covered for data contracts that you think folks should be aware of?
Yeah, I mean, I think one of the things around contracts where we haven't spent a huge amount of time yet. I mean, Shashanka kind of mentioned this in some maybe in a more roundabout way, is that I think contracts are bidirectional. So not only are they for enforcing on the producer side, what data needs to come over the wire in what shape, or not necessarily over the wire, but even from one table to another table. I think that the contract can also be used to ensure that the data is being used in the way that is expected, meaning it's only shared with, or it's only accessed or forked in situations where that's okay or it makes sense. For GDPR is a great example. Like, is the data actually being used in the model or the analytics dashboard that we decided it would be used and nowhere else? And is the data downstream, being refreshed at the cadence that we expect? If this has become an orphan table that some product manager asked for 3 months ago and hasn't accessed since, then I think there's a real question to be had around whether or not that contract needs to continue to be supported.
Sure.
The other thing I would say is another big use case is data modeling and data architecture. One major challenge that a lot of data engineering teams or analytics engineers have is that they're basically faced with this mess of spaghetti SQL at the company, and all the company's core analytics and other data operations are derived off of that. And it seems like that the only way out of this kind of nightmare situation is through a large scale refactor. And I've seen this happen many times where a data engineering leader comes in and says, hey, we need to rebuild everything, we'll refactor everything, we're going to create an entity model, we'll get the whole company to shift onto it. And it ends up taking this like 2-year-long effort that nobody really wants to do. And it's really hard to gain traction. And a lot of these things kind of fizzle out halfway. And my perspective is that if you have an object, if you have some asset where you can improve it iteratively over time in small ways, right? I want to add a foreign key to the contract. I want to add some constraints to that foreign key. That's actually one really great mechanism to do data modeling in a very iterative way, based on the use case, instead of trying to go through these large scale changes. So yeah, that would be the other use case, I think, for contracts. But I always recommend not starting off that way, because it's much harder to tie data modeling efforts explicitly to revenue outcomes. And it's much easier to do that when you're focusing more on the quality of some revenue generating asset. And that gives you the goodwill in the company to invest more time and energy into improving contracts.
Or the comfort that your data is being managed and handled in the right way, which is kind of the governance and compliance side of things.
Right.
Which reminds me, one of the things I kind of realized while trying to apply data management primitives to data contracts was that, normally we think about the data contract as being one-for-one with the raw data asset, and attached to it, where you've got a table maybe, or a stream, and you've got a data contract that goes along with it and tells you certain things about it. When it comes to things like access management, retention, these kind of things, it's nice to have these abilities at that leaf level, at the specific data set level, but really for more scalable management, you also want it at a more logical level. So I think there's also the case to be made for data contracts that cover groups of data sets versus just a single data set. So I want to be able to say things like, I've got a data contract that covers all data that contains PII, and the contract that covers that is so and so. And so you can use kind of classification terms and other kinds of categorical terms as an indirection layer to essentially create logical contracts that are almost like policies written as code or as config, really, in this case. And so that, I think, is a scalable. I think we'll talk about scalable management of contracts, and I think that's kind of an interesting thing around it.
Well, and so Shashanka, I want to push that a little bit further. This question just came in on chat. The question is, it seems that a data contract is the implementation of a data product. And so kind of thinking about this one-to-one versus one-to-many, can you expand on kind of why a data contract versus a data product, or kind of like the intersection of those two?
Well, at least in terms of, Chad is the English major here, but and he can correct me if I'm wrong, but I think, the data product is more like the noun that's the actual thing, right? So it could either be a data asset on its own, like, a snowflake table might be, for a company, a data product. And in other cases, a data product could be a collection of data assets, like every table in this particular relational schema is this customer product, let's say, right? And so I think products tend to be thought of, can be either one-for-one with a data set or one-to-n. And so that could be, you can think of it from an ER model, like one-to-n relationship between a data product and a raw data asset. And I think data contracts have a similar relationship, which is they could also be one-for-one with a data set, like cover exactly one physical data asset, or they could also be attached to a group of data assets, and that could then lead to a logical data contract. But the things that they are and the things that they do are slightly different. Now, when it comes to specification languages, I think we might see some sort of a common lingua franca emerging for how we represent these things in YAML, right? Like at the end of the day, the specification language will look like, I've got a name, I've got owners, essentially this is just metadata about this thing that we are trying to describe, written up in a language that programs can interpret and do interesting things with. Curious to hear your thoughts on that, Chad.
Yeah, I agree. I think that sort of delineation is the right one. And the way I've always thought about it is you can have multiple data products that all rely on the same set of data contracts. Like, so for example, I might be building a machine learning model that consumes pricing data from a Postgres table. And I really need that pricing data to be under contract, right? I can't have a column called dollars and cents all of a sudden change to be, dollars expressed in dollars. But that very same data might be useful in another data product that maybe is looking at, it's predicting customer churn based on spend over the last 30 days. So I always see I see contracts as inputs to data products, and basically as APIs, and the mechanism on top of which actual data products can be constructed and fulfilled.
Awesome. All right, let's move on. Let's move on to our last section. So we're going to talk about kind of more concrete implementation details. So kind of like, how do we actually implement or start to use data contracts? So if we think about the use cases that we just reviewed, and I've been taking some notes as we go, so hopefully I captured the majority of them. But the use cases that we've discussed so far as to why data contracts, it's building data resources specific for downstream consumer use cases. So not just creating data for the sake of data, but actually creating and emitting data for revenue driven or driving use cases or kind of like core metrics, defining SLOs or SLAs, defining data quality rules. So really defining the expectations of the structure, the contents of the data. Like Chad was saying, if it's a dollar cent column, it should show up in dollars represented as cents, not dollars represented as dollars. Ensuring once data is then forged or consumed downstream that it's done so appropriately. And then is it actually continually consumed downstream? So if we build a one-off data set for a one-off use case, understanding kind of the expectations of that consumption and then deprecating it as need be. And then also data modeling or building out data architecture. So there's a ton of variety in use cases there. So let's talk about how we actually start to implement those. And Chad, I'm going to actually start with you on this one. Can you give us some concrete examples of how or where a data contract fits within our beloved term, the modern data stack? Like, what is the artifact that is represented within a data stack?
Yeah, that's a great question. So when I think about, I do think that data contracts, at least at first, are generally going to be seen as an extension of the data quality initiative. And I look at data quality in basically two sides of a coin. On one side, you've got sort of detection mechanisms of if a thing breaks, if something goes wrong, how do we know it went wrong? And how do we find the potentially root cause, the source of that failure? And then on the other side, we have prevention, right? So this is stopping the potentially breaking things from happening in the first place. And this is where I see contracts initially finding a lot of that hold on companies who are beginning to invest in them. And I believe that you can initiate a contract really anywhere that there's some handoff between a producer or a consumer. And it could be a consumer that doubles as a producer. It might be a data engineering team or an analytics engineering team that owns a table in Snowflake or something like that, and that data is being consumed many places downstream. That's somewhere where you might want to put a contract. But in terms of the mechanism, the sort of technical mechanism of where to start, I think some form of schema definition is key. So you could use protobuf or Avro or JSON. I always recommend storing the schema definition of the contract in some registry. If you're using Kafka or Confluent, then the Kafka schema registry is great for this because it has a lot of great functionality associated with backwards compatibility checks and things like that. But you can also store contracts in like GitHub. That also works totally fine. And then there needs to be some mechanism of enforcement. So at the beginning of the sort of presentation, this is the two halves of data contracts. Is you have to have some vehicle for defining, for discovering your contracts, like some cataloging type system. And then on the other side, you need some mechanism of saying, hey, the contract has been violated, and being able to take some action based on that. I think in general, there's three places where you can take that action. One place is during the actual CI/CD workflow. So as a change is being made, breaking a build before the change is merged. So this might be, introducing the schema breaking changes as one example. The second place where it's important to have some level of enforcement is on the data itself. So if you're using a stream processing system at Convoy, we leveraged a KSQL and Flink. So as the data is essentially passing from one system to another system, you can run a check. We leverage CDC as well, so you can run a check on each sort of row level piece of data to say, does this row meet the contract? So as an example, you might say, I always expect a column called the tax identification number to have 17 characters. And this number has 15. And now that violates the contract, and therefore it doesn't make it into the data pipeline. Instead, we'll push it off to a DLQ and potentially alert the engineering on-call. And then the third and final place where I think it's pretty meaningful to have some type of enforcement is in like a general like monitoring layer. So as after the data already arrives, you can look at the statistical distributions of the data and have metadata added to the contract about that. Like we never expect the range of some data to ever be greater than X to Y, and then that could go to an engineering on-call as well. So just to summarize, two pieces, I think a contract sort of definition and discovery, and then the actual enforcement of the contract. And I recommend, protobuf, some type of schema definition, serialization framework, and GitHub. And then on the other side, like some place to run monitors, institute breaking changes, and then push bad data somewhere to be reviewed by the engineering team.
Sure. So I mean, I think a lot of those are kind of driven with a focus on data quality, which obviously is a huge component of it. Shashanka, I'm going to kick the same question over to you in terms of where data contracts can kind of sit within a stack. If you've seen anything either internally at LinkedIn or within the Data Hub community of, kind of concrete examples so folks can kind of conceptualize how they could start implementing it within their stack.
Yeah, I think the structure of it in general always has mirrored kind of what Chad just described, which is, you have a declarative form of the data contract. In many cases, people are reusing schemas for it, but a contract has a schema, but it may not be a schema. So you could potentially have a contract definition language that is different than a schema definition language, but might be a superset of a schema definition language. It might include a schema. And then, that gets checked in, you have a CI/CD thing that runs, and then that either validates if the contract seems to have evolved in an unexpected way or not, and then sends it off to everyone that needs to care. And I think that's where it gets interesting, because I think where we are headed as an industry is a place where the contract is not just located inside a contract registry, but it's actually free flowing within your entire data stack. So every single system that works with data is aware of at least an aspect of the data contract that it cares about. So for example, if you're a data quality tool, then you will be listening for data contracts that affect your operations. So let's say, 5 minutes ago, someone checked in a data contract with a quality rule about a data asset, and you are a data quality system, you should be essentially listening for data contract changes that are happening in your ecosystem, and you'll observe that there's a new data set that is now under management, essentially, for you, and then you'll start acting on it accordingly. Similarly, you might be a data retention operator, right? And your job is to just make sure that all data assets under management are being retained correctly. You would be watching for data contract changes that are happening that affect your operation. So if there was a new retention spec that came in on a particular policy, you're going to take action on it. So I think in terms of what I've seen in our community, we've seen, of course, at LinkedIn, we built a large part of this, and I was kind of building a lot of this by hand there. But I've seen kind of similar approaches in companies like, Optum, Saxo Bank, Zendesk. Stripe is doing interesting things with observability, where the data contracts are kind of encoded in the Airflow DAGs, and they're using kind of Data Hub to monitor, as Chad was saying, and alert on SLA violations. So what I think is going to happen is this idea of data contracts as a metadata fragment that will activate operators inside your entire data stack. And we'll see Flink, Kafka Connect, Debezium, and all of these different systems in the operational streaming stack. And then we'll also see, the data quality tools, and we'll see the data management tools, everyone kind of starting to be responsive. And I mean that in a systematic way, like their system becomes responsive and reactive to changes that are happening to data contracts. And the contracts registry will, I think, evolve to becoming sort of the data definition plane for data itself, which I think is very exciting.
I think so I want to take a look at one of the questions that was submitted, because I think this is an interesting intersection of kind of internal use cases, but kind of also these boundaries of control, right? Like where you have control over the quality or the availability, or kind of all of these ways that we've talked about, or all these things that we've talked about that data contracts can resolve. But so one of the questions is, can data contracts be used in scenarios where data producing systems is managed, or a data producing system is managed by a vendor or a third-party platform? So something like Apple, Google Analytics, Facebook ads, like all of those things where you really are just kind of a recipient of the data, and you're at the mercy of how that data shows up.
Well, I think at least we can start with the monitoring approach by essentially creating a contract that at least asserts for your own sanity what you expect from the data, so that at least it's the first line of defense, and you can protect bad data from like impacting everyone downstream of it. And you can at least isolate when breakages happen, whether it was because that particular dump was bad or whether there was further data processing that caused errors in your pipeline. I'm a big believer in kind of the proof by induction. So like if you have multiple steps in data transformation, and if you have proof that the inputs were clean, and that should therefore imply that the outputs are clean unless proven wrong, and you can kind of move that argument forward.
Awesome. So we're getting a little close on time. So we'll do a couple more questions here, and then I want to save some time towards the end for some closing thoughts, and then any questions or follow-ups that are live. So Chad, I'm curious, either in your kind of day-to-day work historically, or maybe the things that you've seen within talking to other folks in the community, how have folks managed, or how have folks kind of attempted to manage data contracts at scale? Particularly once you figure out like that entry point of kind of proving the utility within an organization, but then really starting to roll it out across disciplines, across teams, across systems. What are the complications that come up? What are best practices that you've heard? So yeah, what does data contracts at scale kind of look like?
Yeah, so data contracts has a very long tail of success and efficiency. There's sort of starting from the very beginning, really where we focus most of our time, as Shirshanka was saying, was to start with a single business use case that we felt incrementally could, every incremental improvement in accuracy led to some equivalent or greater improvements in actual business value. Once we achieved that, that's when we started investing more in a platform-based solution. The big challenge to contracts is actually less of a technical challenge in a lot of ways, and more of a social, cultural challenge of how do you get people who don't really think that much about downstream data use cases to change their job and their work to where now they are thinking about it and they're playing an active engineering role around the data. And really, so I actually rolled out essentially a maturity curve of data contracts at Convoy, and of each team potentially might follow. They may be at a different place in that maturity curve. So the first step is awareness, and this is of course after your initial like POC, right? But the first step is really awareness. It's just, is your engineering team aware of how the data is from the systems that they own is being leveraged downstream? There's a bunch of technical vehicles to accomplish that. We use data lineage. So we essentially had a mechanism of defining, what is the downstream data set that needed to be under contract. And then at the column level, understanding like which source systems fed into that contract, and then providing some insight into that. So anytime an engineer went to make a change, we would show them quite literally what was going to happen and who would potentially break and what was that use case and how important it was. And that went a really long way in generating accountability. What started off as essentially saying, look, our data platform is a black box. We don't know what goes into it, nor do we know what comes out of it. There started to be some awareness around like, oh, wait a second, if I do this change, then I could potentially introduce a SEV 0, and that's bad. And I probably should go have a conversation with that person first. The next stage is actual ownership, and that is the mechanism of implementing and defining the contract. Like I was saying, we did this through a schema registry and using a schema serialization framework, and we had a library. So there was an SDK that software engineers would use to actually define their contracts and push new versions of the contract. And if changes were backwards incompatible changes were detected, we would break their build, and that all of that was surfaced in their GitHub flow. That was really great for them. And this is just sort of a product development principle of mine, is like you need to meet people where they are and try to introduce as little change to their existing workflows as possible. I think the more deviation from their existing workflow that you try to implement, the harder it's going to be to roll out at scale. But if this is just like part of a regular engineer's job, like, yeah, I need to do integration tests. I need to do, monitoring on important data sets, and they have all of the tools fit their existing stack, then it's no problem. And then I would say the next step is to introduce the constraints, and to introduce those constraints gradually over time and not all at once, right? Instead of saying, hey, there's 50 things that I now need you to think about, and there's 20 semantic rules and a bunch of different distributions. Instead of that, just starting with 1 or 2 constraints that are really meaningful and pretty easy to debug, like I need this column to not be null. That goes a long way in just helping the engineering team, like really learning the ropes of sort of data management from the producer side. And then obviously there's a long tail of constraints, and there's a lot that we can get into. I saw some questions in the chat about, how do you detect some of these more subtle business logic changes that don't necessarily violate the schema, and maybe you can't even catch in a distribution. I think there's a lot of really interesting things that you can do. So for example, for those types of changes, we actually had an alert. So like it was all metadata, and someone could define like what the schema of a particular table or column was supposed to be. Like this table represents, feet or represents distance in miles or something like that. And if we detected a change was being made to that column, we could pop a little alert that says, hey, this column is supposed to represent, distance in miles. Does it still mean that, or does it mean something different? Because it's under contract. And just those little nudges is oftentimes enough for people to at least double check what their code is doing. So that's sort of how I would think about managing this stuff at scale. At first, we thought of it all as components. Each one of these parts of the lineage and the schema enforcement and the monitoring, they're all separate components. But in the ideal system, you could tie all these together. So it's single and fluid.
Definitely. So we are getting a little close on time, but Shashanka, I want to see if you can address this one of the questions in chat, specifically around I just lost it. There we go. How data contracts can be modeled and maintained in a data catalog at scale. Can you answer? Do you have thoughts on that in kind of like 1 or 2 minutes?
Sure, I think, and it's related, I think, to the challenges in managing a large volume of contracts in general. First of all, the cost of creating a contract itself is non-trivial, and so you do want to make sure that you're creating contracts on the most valuable data assets. And so that's actually a chicken and egg problem. Like, how do you know what's an important data asset so that you can go create a data contract on it? And the catalog actually, or the metadata graph, comes to the rescue in more ways than one. Chad talks about lineage being a huge enabler of that. And you can use that to also determine essentially the innate value of a data asset. How often is it getting used? How much does it get used by downstream assets that are also important? So essentially giving the equivalent of page rank to a particular asset based on how important the downstream is, allows you to understand which are the assets that you need to be focusing your time on. And once you do that, then you can actually bootstrap a lot of the initial contract creation from the catalog itself, because in many cases, especially with modern catalogs, I mean, Data Hub, of course, but I'm sure there are more than Data Hub that do similar things, where you're actually building that full metadata 360 picture anyways. You've got the schema, you've got the quality assertions, you've got data profiling results, all of that coming in to create that one consolidated picture as seen by the facts on the ground. And from then on, you can actually bootstrap the first default contract proposal pretty easily. And so that allows you to kind of bootstrap a large set of contracts for the most important data sets very quickly. And that's, and that's not just a one-time thing. The important thing is, your data ecosystem is changing constantly. What's important today may actually fall out of importance in a quarter from now. And so being able to continuously be able to understand what's happening on the ground and then using that to drive, okay, I think this thing needs to be under contract. Here's a proposal for that contract. Should be get that lightweight conversation happening between the consumer and the producer. Then you lock in the agreement and you're off to the races. I think that's really the key to making sure that this doesn't slow down the business and keeps things going at as fast a pace as they used to without contracts and with safer data, I guess.
Sure. All right, folks, we are pretty much at time. Chad, is there any parting thoughts you would like to provide the audience?
Shirshanka actually really summed up, I think, the overall theme of data contracts well. And this is something that I care about a lot personally, because what I've observed at Convoy and other places is that data teams are many times devalued because the core of our work seems to revolve around analytics. That doesn't mean that there's anything wrong with analytics. However, if analytics could be 5% wrong and the business doesn't care, it creates a lot of if the C-level leadership then is sort of weighing who has more value at the company, the person maintaining a dashboard that nobody's looked at in 6 months, or some software engineer that's building a feature that's making money. It's a very easy conversation to have in times like these, who gets let go. And I think the way to make the data practice a lot more robust is to start from those use cases that are actually very valuable, or at least to transition the data practice to focus on those use cases. And I think contracts are a technical mechanism to start doing that. And then the last thing I could do, just as a quick shout out, I do run a community called Data Quality Camp. It's a Slack group. You can get there by just saying dataquality.camp /Slack. We talk about these things all the time, and we would love to have folks from this conversation join us there as well.
Definitely. And I'll be sharing the recording out as an email. I'll be sure to link that. Chad will also have it on our YouTube page with those links as well. Shashanka, final thoughts?
Well, I think we're already doing data contracts in some way or shape. They're encoded inside, your DBT tests, and they're encoded inside maybe your data quality tool, and they're maybe encoded inside your Airflow DAGs. And so it's already something you're doing, but maybe in a somewhat disparate way, spread across multiple tools. And so really don't think of it as, oh, this is a net new thing that I have to start from scratch, but think of it as really an evolution of something that we've all been working on as an industry. And this is just saying, let's actually do more of it, and let's do it in a consistent way rather than interspersed across various different tools in a haphazard way. That's really, I think, the way to think about it. So that's what
Awesome.
I would say.
All right, folks, thank you so much for joining. Like I said, I will be emailing out this recording to folks that RSVP'd. If you just happen to get the invite and you didn't RSVP, don't worry, we will be sure to post this on the Data Hub YouTube channel, so you can take a look for it there. But thank you all so much for your time and your attention. I know I personally learned a ton. Chad, thanks for joining us, and we will talk to you all very soon. Have a wonderful afternoon.
Bye-bye.
We'll see ya.
Thanks, everyone.